ladies and gentlemen.
Let's talk about angles. So, angles are formed when you have intersecting lines, line segments, rays. As long as we have some sort of intersection there, or they meet at a point, we have an angle. An angle can go by two different names. If we have a point on each ray and the point of intersection labeled, we can label it as point on one ray, the intersection, and then the point on the other ray. For example, angle ABC. Or if we just have the point of intersection, we can label it by that point of intersection, so angle B. The reason why we may use 3 points instead of one sometimes is we may have multiple angles that we're talking about through the same midpoint there, the intersection point. So in that case, we would need to very much specify which ray we're starting at, the middle, and then which ray we're ending at. There are some angle relationships that you need to know. So the first one is when you have intersecting lines. So you can call them intersecting angle pairs. In my classroom, we call them vertical angles. Basically, angles across from each other in an intersection. As long as the two lines intersecting are straight, then the angles across from each other would be equal or congruent. So we would say that angle A is congruent to angle C, or we could say that angle B is congruent to angle D. Now in this case, we didn't label the intersection point, so sometimes we can just call angles, like we did with lines, their own name. So if we associate it like this, we're saying that this opening here is B, then we can just call it angle B. So keep that in mind. Notation's a little bit nuanced here and there. These vertical angles, as we just talked about, are two opposite angles when we have intersecting lines, and they always have the same measure. So if one is 45 degrees, the other is 45 degrees. If one is 70, then the other one is 70, so on and so forth. Supplementary angles. So if I take two angles and I say that they share the same ray for one of their rays, and the openings themselves, not a very good job, make a straight line, then those angles are supplementary, and they have the property of adding to 180 degrees. So if I take a straight line here, wait for it, there we go, and I split off of that another ray, and I call this angle A and this angle B, then A plus B has to equal 180 degrees. So not too bad. So in isolation, we have those. If we introduce parallel lines, then we have quite a few more. So let's talk about those. So in parallel lines, we have all of these lovely angles here. The first angle pair we're going to talk about is corresponding angles. Those are angles in the same position of the intersection. So if you notice that A is in the top right and E is in the top right of those intersections, those are corresponding, and corresponding angles have the same measure. So we would say that angle A is congruent to angle E, and we can say because of corresponding angles. The next one is alternate interior or exterior angles. So if we look at this line here, this transversal, as its own thing here, if we are on opposite sides of the transversal, and both angles are either in between the parallel lines or both outside of the parallel lines, then those are congruent by alternate interior if they're in between, or alternate exterior if they're not angles. So for our intents purposes, we could say that angle C is congruent to angle F by alternate interior angles, or we could say that angle B is congruent to angle G by alternate exterior. So B and G are both outside and they're on opposite sides of that transversal. C and F are both inside the parallel lines and both opposite sides of that transversal. So those are your main ways of congruent angles. As far as supplementary angles go, we can look at same side interior or same side exterior angles. And those always sum to 180 degrees. So if I redraw our lovely parallel line diagram down here, so I did it a little bit differently. If this is angle A, B, C, and D, we would say that A plus B is equal to 180 degrees because they're both interior angles and they're on the same side as that transversal. C plus D is also same side interior. For the same reason, those have to add up to 180 degrees. Now if I erase these and I instead replace them with A, B, C, and D, all of those relationships are still true. A plus B is equal to 180 degrees because they're on the same side of the transversal and both outside of the parallel lines. So, not too bad. Let's throw all of this together and try out a question, shall we? So, in this diagram here, lines L and M are parallel, so this line is parallel to this line, and they are intersected by line N, that's our transversal. What is the value of x minus w? Well, we are given this 70 degrees here. And since this 70 and w are across from each other in an intersection, they are vertical angles, which means that w is equal to 70 degrees. And then 70 and x are on the same side of the transversal and both outside of the perpendicular lines, meaning that they add up to 180. So 180 minus 70, well, that would be 110. And then we are asked, what is x minus w? Well, x is 110 minus 70. Well, 70 plus 30 is 100. So plus another 10 more gets us 40 is the difference between the two. And that would be our answer. So not too bad. A lot of memorization though, but it makes sense. You don't have to memorize all of the pairs. Honest to goodness, if you can remember that the corresponding angles, the angles in the same position of the intersection, are congruent, that two angles that make a line when they come together are supplementary, and that angles across from each other in an intersection are congruent and vertical. If you have those three things, you can get everything else. You can work towards everything else as long as you have those three things known. So the other, if you memorize it, it's just the sprinkles on top. If you have any questions, let me know. Otherwise, I look forward to seeing you in the next video.